Alright guys, so what I'm going to be doing right now in this video is I'm going to be going over the first and second page of your practice exam. So hopefully it'll only take about 10 minutes. I'm going to go over the multiple choice and then I'm going to go over number 17 and number 18. So feel free to fast forward me if you feel like you understand things. If you don't, you can repeat me. That's perfectly fine. Okay, so I'm going to start with number 1, which states, all atoms of the same element have the same blank. Okay, so let's look at these options. Same number of protons. Well, that's a viable option because yes, all atoms of the same element do have a specific number of protons. That defines what type of element you have. So I'm going to leave that as an option. The same number of neutrons. Well, here's the issue. You can have a specific atom, okay, of an element with different numbers of neutrons. So one can have, let's say, 6. One can have, let's say, I don't know, 8. So for example, carbon. Carbon has 6 protons, but some of the time it has 6 neutrons. Some of the time it has 8 neutrons, which leads to carbon-12, which is one of its isotopes, and carbon-14, which is another one of its isotopes. So no, it's still considered carbon, but it has a different number of neutrons, so that doesn't work. That answer is wrong. Okay. As a result, isotopes also have different mass numbers. Remember, your mass number is your number of protons plus neutrons. So while carbon-14, right, and carbon-12 are still considered carbon, they have different mass numbers. And mass just makes no sense at all. I don't know what I'm talking about with mass. You need to be more specific. So the answer is A. Okay, let's go on. 2, the average atomic mass of an element is the blank. Okay, the total number of subatomic particles in its nucleus. So what that would mean I would have to do is take my protons plus my neutrons plus my electrons, which makes absolutely no sense. We've never done that before for anything, so no. The weighted average of the masses of the isotopes of the elements. What that means is you take the mass numbers, okay, and then you find their weighted average, meaning you take their percent abundance and you add up all of those. So for example, if it's, let's say, one atom has a 92% abundance, one isotope has that, and one has an 8% abundance, you would multiply one mass number by this and the other mass number by this, and you would add them up. Okay, so we'll get into specifics when we get to that part of this practice test, but that's your answer. It's a weighted average, B. None of the other answers make any sense. All right, for 3, what is the approximate frequency of a photon having an energy of, okay, well, I've given you energy. So in this problem, guys, if I give you energy, you look at your green sheet on the test. Well, it's going to be white. Right now, when you're at home, go online and look up your cheat sheet. Okay, it's up on the portal, and I've actually posted it to right next to where you found this video. So look at that, bring that up on your screen, and what you'll find is you have the equation E equals HV. Okay, V being your frequency. So I know my energy, I'm given it in this problem. So that's 5.0 times 10 to the negative 24th. I know H, because H is given to me on that reference table. It'll be given to you on your test. It's 6.626 times 10 to the negative 34th. And I don't know my frequency. So to find my frequency, I need to divide both sides by 6.626 times 10 to the negative 34th. So you're going to do 5.0 times 10 to the negative 24th in your calculator, divided by 6.626 times 10 to the negative 34th. Remembering to put 6.626 times 10 to the negative 34th in parentheses. Otherwise, it's going to mess up your calculation. What you should end up getting is A. Okay, let's look at 4. When an electron moves from a lower energy level to a higher energy level, the electron, okay, always doubles its, no, well, that makes no sense. Doubling energy, we've never talked about that, okay? If it's going from lower energy to higher energy, it's not getting closer to the nucleus, it's getting farther away. Let's look at these 2 different answers. Guys, remember, we had that table in Unit 5 where you looked from, let's say, here's your nucleus, here's one energy level, here's a second, okay, here's a third, here's a third. If your electron moves from, let's say, the first energy level to the third energy level, it's going to it's going to absorb a specific amount of energy. It's not going to be continuous. Imagine these are like rungs of a ladder. Okay, it's a specific amount from 1 to 3, from 1 to 2, from 2 to 3, etc. And we call that specific amount a quanta. So your answer is C. It's a quantum of energy. Okay? Number 5. What element has the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p2? Okay, so all you have to do, open your periodic table. Okay, find 3p. And I'm starting at aluminum. If I'm at 3p and 3p2, that would be Si. Si would be my unit. Okay, so my answer is going to be C for that. That should be a pretty easy answer. 6. Which of the following sets are the charges given correctly for all the ions? Okay, this isn't a trick question, guys. Let's look at A. Is the charge of Na supposed to be +1? Well, yes, it is. What about the charge of Mg? Is it supposed to be +1? Well, no, it's not. So therefore, that answer is wrong. Okay, so cross out A. That doesn't work. What about B? Is my charge of K supposed to be +1? Yes, because it's in group 1. Sr is supposed to be +2? Yes, it's in group 2. And O is -2 because it has 6 valence electrons. So it's going to gain 2 to get a perfect 8. There you go. There's your answer, B. And guys, please be writing on the line, or else my life is really hard when I'm grading. Okay? Which of the following statements correctly compares the relative size of an ion to its neutral atom? Well, let's look at the difference between an anion and a cation. An anion, negatively charged. Anion is negative. Cation, remember, positive. I know you laugh at me, but I know it helps. Okay? If your element is negatively charged, what that means is that it has more electrons than the original element. The more electrons you have, the more they repel each other. Okay? Therefore, the larger it's going to be. So the more negative you have, the more electrons. More electrons means you're going to be bigger. Okay? More, and then the fewer electrons you have, okay, the smaller you are. Alrighty, so my answer is actually A. The radius of an anion is greater than the radius of its neutral atom. Perfect. What is the formula for sodium nitride? Alrighty, we got to remember our charges. Na has a +1 charge. N has a 3- charge. Cross my charges. And I've got Na3, N, which is C. Okay, let's look at 9 together. What is the difference between a mixture and a compound? Remember, guys, mixture is a bunch of compounds together. So a compound consists of more than one phase. I don't even know what that's talking about, right? A compound is just one, it's like water, for example. You've got atoms bound together, and it's going to be a repeat of those. So that doesn't make any sense to me. Okay, a compound can only be separated into its components by chemical means. Remember, chemical means of breaking it apart would be called decomposition. I like that answer. A mixture can only be separated into a component by chemical means. False. I can do it physically. And a mixture must be uniform in composition. No, you've got heterogeneous mixtures, right, that don't have to be uniform, right? Think about vegetable soup, for example. That's a mixture that's not consistent throughout, okay, uniform throughout. Okay, the expression, we're on to number 10, next page. The expression of 5,008 kilometers in scientific notation. Well, to write in scientific notation, guys, you want to be between the numbers of 1 and 10. So what I'm going to have to do, I'm going to write this number out again, 5,008. I need to move this decimal, it's an implied decimal here, okay, to make this number between 1 and 10. So I'm going to move it 1, 2, 3 places. So what that means is when I write it in scientific notation, it's going to be 5.008. Okay, 008 times 10 to the, here's the issue that some people had. Is it negative, is it positive? Well, I took a big number and I made it smaller. So I need to make up for that fact by making the exponent positive. So it's going to be 10 to the third. Okay, if you want to check it, basically what you're doing is you're saying 5.008 times 1,000. 5 times 1,000 gives you 5,000. That should make sense. Okay. 11, I tricked a lot of you. I'm sorry I did, but I did. All it's asking about is draw the dot structure for nitrogen. All that's meaning is how many valence electrons does nitrogen have? Ground state meaning when it's not an ion, when it's a stable element. So when you look at how many valence electrons nitrogen has, it has 5. Okay? If you're uncomfortable with finding number of valence electrons, either email me and tell me you need a video, talk to a friend, figure it out, or email me and I can answer your question directly. Okay? What is the measurement? 111.009 millimeters rounded off to 4 significant figures. Okay, so remember, I want only 4. Okay, so let's try this. I've got 1, 1, 1, that's 3 sig figs, and I want just one more significant figure. So there's a 0 here. This is a 0, so this is just going to stay 0, guys. Okay, there I've got 4 sig figs. Remember, you count from left to right if your decimal is present, so 1, 2, 3, 4. 4 decimal places. Sorry, 4 significant figures. Okay, so my answer is B. What is the density of an object having a mass of 8 grams and a volume of 25 centimeters cubed? Well, what's your formula? Density equals mass over volume. No, guys, I'm not going to give this to you on the test. So you've got to remember it yourself. So I'm going to take 8 and divide it by 25. Okay, and you should get, I believe it's A for your answer. Okay, so just be careful. All right, which element requires the most energy to remove an electron? Guys, this is another way of saying which element has the highest ionization energy. And remember, your ionization energy is the exact opposite, has the exact opposite trend as your atomic radius. So as you move across your periodic table, okay, your ionization energy actually increases. As you move down your periodic table, your ionization energy will decrease. So for this to have the highest ionization energy, the most energy to remove an electron, you want to be farthest to the right and highest up. And if you look at the periodic table, that's what nitrogen is. It's highest up and farthest to the right. 15. An ionic bond is between, well, we know it's between a metal and a nonmetal. Okay, so let's get rid of some answers. That's wrong. It's not between 2 nonmetals. It's not between 2 metals. I don't really know what that's talking about, but if you think about it, metals have a positive charge, which makes them cations. Nonmetals have a negative charge, which makes them anions. So A is your answer. Okay? Last multiple choice. When we discuss a mixture, what state of matter would we designate for that mixture? Remember, liquid, the only time we're talking about a liquid is if it is a pure liquid. So for example, H2O all by itself with nothing in it is a liquid. Okay, if we take salt, NaCl, and add salt to our water, right, and shake it up, so now we suddenly have salt water, that solution is now aqueous. So yes, I know in everyday life you only think about things being liquid. In science, we have 2 different types of liquid. We have a pure liquid, so just H2O, or a mixture that's a liquid, and we call that aqueous.